We show a lot of satellite imagery on Weather World in our forecast segments, but that's really just the tip of the iceberg. There are many products derived from the conventional imagery, and I'd like to show a few in the context of some recent weather events. And I'll start with a winter application. Here's a close-up last week of the Gulf of St. Lawrence in southeastern Canada. This time of year with snow and ice on the ground, it can be tough to tell what's cloud and what's not. Check out the white swirly structures over the water. My first guess was these were small-scale cloud vortices that sometimes form over water bodies in winter. But when we loop the image, we see plenty of clouds racing off to the northeast, but those swirls of white hardly budge. Turns out these are actually ice flows on the river, not clouds. That's why they hardly move. To figure out these were ice, I used a special satellite image that combines infrared and visible radiation. Clouds composed mainly of water droplets still look white in this hybrid image, but snow and ice appear bluish. Notice much of the area has that tint because there's snow on the ground, and the ice vortices look bluish too. A quick and easy way to distinguish clouds from snow and ice. Now let's head to a warm place, the middle of the Pacific Ocean, focusing on Hawaii, where last week was unusually stormy. Here's the water vapor loop from last Monday and Tuesday. You know we use this loop to visualize the upper level winds. Here we put on some wind barbs derived from the vapor imagery. Notice there was a sharp trough or southward dip in the flow just to the west of Hawaii. From these satellite winds, we can estimate something called upper air divergence. That is where air is spreading apart at jet stream level, which is favorable for active weather. Here, positive numbers mean that divergence. Notice it's focused on the northern Hawaiian Islands. And this colorized infrared loop shows thunderstorms developing and moving over that area of upper level divergence, especially across the island of Kauai, where as much as 3 feet of rain fell. Truth is, out over the ocean where we have very little direct observations, this type of satellite product really helps forecasters. Finally, let's look at a satellite-derived product from March 2nd, the day of the deadly tornado outbreak in the Ohio and Tennessee valleys. This shows something called the lifted index, which is a measure of instability. Here, the colors in the warm sector of the low, between the warm and cold fronts, indicate that the atmosphere was rapidly destabilizing early in the day, a tip-off to the severe thunderstorms that developed later. Most of these derived satellite products are created at the Space Science and Engineering Center at the University of Wisconsin, which is well known for its research and development in satellite imagery. The center was founded by Dr. Werner Suomi, who pioneered satellite remote sensing in the 1960s and who is widely recognized as the father of satellite meteorology. In fact, in January, NASA renamed its newest Earth-observing satellite in his honor. Fred will be back with the extended forecast next.